Hey everybody, it's Ethan, and I'm here with Drew, and we're going to talk about a conversation, not a conversation, but I heard a presentation from Cisco at a networking field day that I was taking part in recently. And Drew, Cisco they've made some pretty public announcements about this. They want to build your AI data center. That is, we're not talking about AI for operations today, but AI, actually the network that supports AI computing, I think is a good way to put it.
Meaning for the enterprise customer, that's who they're targeting here, not the hyperscaler in this case, or?
That wasn't clear to me that it was necessarily that. I don't think, if I'm Cisco, I don't think I would have limited to that, because they were talking about an AI cluster design that would support as many as 32,000 GPUs. And I don't know too many people that are building that in the enterprise. That's a lot of GPUs. It's a lot of capital to tie.
Well, that's the max, though. If you're a big bank or whatever, you could probably.
But just to the point, to say, I don't think they're limiting to this to enterprises. That is, I mean, you could be a neocloud and maybe use this and so on. Now, they did in the presentations, they were talking about what this network would look like. They did make a distinction that if you're going hyperscale, like really, really, really big, that those guys tend to have very specialized needs, and they maybe aren't buying a solution from Cisco, all depending on what those very specialized needs are. But by and large, yeah, if you're an enterprise, you could buy this solution. I
think the clue is probably what NAS are you running. If it's going to be a hyperscaler, it's probably Sonic.
I would say so. And in fairness, Sonic is one of the options you could run on this solution, which we should back up a minute. I'm getting ahead of ourselves here. A bit of what this is. But Cisco's got a new switch they've announced. I forget the model number. I think it's the N9300. There were letters and numbers. But it was a joint venture with NVIDIA. And there's some of the silicon in this actually comes from NVIDIA. That's one of your options.
Is it the Nexus 9300?
To build this thing. That sounds right. Yeah. It's the SwitchX silicon that's in that. They announced this, and you can deliver an NVIDIA certified solution using this platform. So Cisco's published a cloud reference architecture based around this, and it is certified by NVIDIA as well. So if that's what you're looking for, that's the hardware platform you want to base this on, and then build the network to support all of that. Cisco can deliver that for you now. And they've got some public articles about this, describing this. They just announced this very recently here. This is November 2025. I don't even think this article's a month old, or this announcement's a month old yet.
Oh, and for context, you actually heard about this from Cisco at Network Field Day 39, yes?
They brought this up, although this wasn't the focus of the discussion. It's more some of the context. They kind of blew through that part of it, because they got into, in the conversation, that they got into the challenges of delivering an AI data center. So if the big image, the big picture is, here are Cisco switches, we are delivering them on NVIDIA hardware, or that is an option, switches with NVIDIA hardware. You can also have switches with Silicon One hardware in them, and do some really cool things on that silicon, by the way. The Silicon One architecture is like, that's interesting. It's very cool stuff that you can do with some of the Silicon One stuff. Cisco began talking about, all right, so if you're a network engineer trying to build a data center that is designed for AI cluster operations, what are the problems that you're going to be facing? What are you up against? And we've talked to some other companies that are talking about this too, Drew. Like, we've talked to Juniper. They've talked about this. We talked to some other folks too. Brain escaping me. But the big deal is, these are not. It's like, it's just another application on my data center. I just make it fast and it's fine, right? No. There's more going on here.
Yeah.
And the more going on are tied to the GPU clusters. So GPUs, when you're doing AI model training, it's a big math problem. There's a lot of math going on, and you are feeding clusters of GPUs parts of the math problem that they work on together. So if you send data, a bunch of data into the GPU cluster, and say one chunk of data doesn't make it to one of the GPUs in the cluster's sitting there going, I'm waiting because I don't have all the things I need to. I can do my next operation. And a lot of the work then that is going on in the network to support AI compute is based around more or less that problem and similar problems where I've got to get all the data to my GPUs in a very timely fashion. We're talking like nanoseconds matter.
Wow.
There's that issue. And then issues of, okay, well, if that's the problem, I have to avoid congestion because as soon as you have congestion, now you've got things that are sitting in a buffer at an interface waiting to go while the buffer is empty because you've got that congestion. And therefore, you need to send communications to different parts of the network and say, hey, don't send to me. I've got all I can handle right now, whether it's an interface that's full or whether it's a receiver, whoever it is you're sending to that's full. And so we're bringing up things like, Drew, all the conversations we used to have with converged fabrics back in the day, and we were running storage across it at the same time. Remember that? We were talking about things like sending ECN notifications, explicit congestion notification, and priority flow control, and that stuff.
It's back, baby.
It's so back. A lot of that, but even more where it's not just you're throwing a PFC policy at it and we're good here. It's like finely tuned, super nuanced, and and how do you deliver that kind of stuff? And Cisco will tell you the answer. It's not just the hardware, and now you're going in switch by switch from the command line and configuring some nasty, esoteric, huge QoS policy. If you Dude, I used to teach some Cisco QoS stuff back in the day. Even delivering something simple was like, holy crap, that is 30 lines of config. Dang. Okay. And that was fairly simple. I can't imagine getting into a data center switch to handle all the things. And Cisco doesn't want you to have to think about it that way. You're actually going to build policies on either. They've got two different products branded Nexus. There's the Nexus dashboard and there's the Nexus Hyperfabric AI. And I haven't done a Cisco data center in a long time. I couldn't tell you the difference between those two, other than Cisco saying, hey guys, we got software that's going to help you tune your AI data center network with priority flow control and ECN and whatever else you need to tweak so that you're creating a fabric that you can count on to deliver data to your GPU clusters in a timely fashion and not run into too much congestion and not deal with all the challenges that you might be dealing with in this sort of environment.
So the Ultra Ethernet Consortium is working on making Ethernet more suited as a transport for data center AI workloads. Is Cisco? I know Cisco's part of UEC. Are these UEC compliant switches?
These are not. The solution that we've got today does a lot of super cool things. Ultra Ethernet is not one of them, and I'll explain why in a second. But backing up, some of the things that Ultra Ethernet is going to be delivering on are things like equal cost multipath, where you're spraying parts of a transaction across parallel links and able to handle concerns like out of order packets and these kind of problems. But although we have a 1.0 spec that is a modest 600 or 700 pages, whatever that monster document was the UEC put out,
it's big.
As far as I know, there's no one that is actually delivering that as a solution yet. It's too soon.
It is too soon.
It's not there. But Cisco is delivering on a lot of the intention of UEC. This is the way Cisco put it, because I actually asked this question about, well, is this Ultra Ethernet, or are we going there? Because it's not just that Cisco is part of the Ultra Ethernet consortium. They are, what are they? They're on the steering committee. It's like they're in it, man. They're committed. It's not like they don't care about UEC or they're trying to don't look over there, look over here. No, they care about UEC, and they'll deliver an Ultra Ethernet transport at some point. But they have a solution that will get you a lot of what Ultra Ethernet will today. They've got boxes with silicon that can do it, and they've got their own magic Cisco proprietary techniques that are delivering some of this stuff, like flowlit dynamic load balancing. So I just got to read you from my notes here. This was kind of cool. If the detected interpacket gap is longer than a set threshold, that next packet is assumed to be part of a new flow and sent to the least loaded link in an ECMP bundle. That jargon I just said is a different way to think about how you are load balancing across equal cost multipath. Typically, what you would do is do a hashing function that is going to do some kind of a computation on source and destination port, these kind of things, and always end up hashing a particular flow to a particular link, which if you've got a big elephant flow, that is not what you want, because you're just going to bury that one link. You want a way to distribute that elephant flow and then subsequent elephant flows that could be coming from the same place across different links. So you get a much more even distribution across your links. That is essentially what flowlet dynamic load balancing is doing by detecting interpacket gaps. Oh, I think that we have a new flow now. It might be a new elephant flow, but I'm gonna look at my links, see who's busy and who's not busy, and send that new flow across that least balanced link, and not rely on a hashing function.
And getting back to the UEC comments, I know Broadcom with, I think it's Jericho 2 ASIC, is providing some features, some capabilities that sound like are also going to come out of UEC, things like ECN and priority flow control and packet spraying, and even taking a frame and chopping that frame up into small pieces so you can spread it across links more evenly.
Now, which of those functions in the UEC's packet spraying might require state? I don't know, but state tracking becomes part of this. If I'm doing hashing, I don't care about state, because I know the hashing is deterministic. I'm going to get the same answer all the time, and the flow is going to follow the same link all the time. With this flowlet game that they're playing, where they're actually tracking interpacket gaps to detect that there's a new flow, my brain went, what? You have to track that state somewhere, therefore. You have to know that, so that as the next traffic from those flows come in, you're sending it across the same link, right?
And my understanding is that, particularly, again, because I'm familiar with the Broadcom stuff, a lot of that state tracking is happening at either end of the connection on, your switches at one end or the other, is saying like, they're using like some credit mechanisms. Like, I've got traffic, I'm open to send and I'm open to receive, and we can share these signaling notifications across the network. So yeah, you're absolutely right. That state is going to be an issue.
Well, so there's the thing you described, and what Cisco's doing here, which is unique to me. I haven't heard about anybody doing things quite this way. They said they're storing state in the chip, in the Silicon One on that you can do that in the
ASIC?
Silicon One. Yeah.
Okay.
ASIC. I was like, well, how many of those can you track? It's like some order of thousands. This chip is a monster. I don't know. I don't know if there's different flavors of the Silicon One chip or something, but this thing is a beast. What this thing can do, and what Cisco was saying, in this presentation, it's like, if you're doing RDMA traffic or Rocky, you really care about this. That what the hardware can actually do, because you got to be able to rely on this thing. They do something different if it's a Spectrum X box with the NVIDIA silicon inside. They do per packet dynamic load balancing, and there's some tagging magic that happens so that you don't have to deal with the out of order. You've got some metadata to help you if there is an out of order packet delivery. The tagging, apparently, with this per packet dynamic load balancing, will indicate to the receiving GPU where in memory that bit of data should go, because RDMA is direct memory to direct memory. Right. So you're not quite so far away with what's going on here. You're just putting a wrapper around it, an Ethernet wrapper around it, and sending it across you're basically doing a memory operation. Anyway. So I guess my point here is, I know we got to wrap this up. I know you got places to go soon. What Cisco is building isn't Ultra Ethernet yet, but it is a certified end-to-end solution with software, a software management layer, and hardware with really exotic, interesting, powerful silicon that you can build an AI data center on, that will deliver you training or inference and help you with all the different traffic management that you've got. If you've looked into AI data center build-outs and looked at some of the architectures that are there, you might have said, oh, well, there's my core where all the GPU magic is happening, and then I got a back-end network that's maybe talking to storage, and a front-end network that's talking to, et cetera. Some of that's even converging now, where this kind of functionality you care about more, so that you can differentiate traffic classes and apply policies to them, and do it in such a way that you don't want to wish you were dead after you got done with it. And therefore the software layer becomes really important. And so you need to have a fully integrated system. And Cisco's like, yeah, we got that. We can deliver it.
They're also really leaning into the fact that it is NVIDIA certified, to give you that extra level of comfort. Like, yeah, we've worked it all out with NVIDIA and we're good.
Yeah, which seems to really, really matter. Because if you're looking for that certified solution from NVIDIA as your vendor, you need the network to be a part of that solution. Absolutely. And not everybody's delivering that. So yeah. So May you live in interesting times. Is that what they say? Or may you not? Maybe you don't want to live in interesting times. I don't know, but
we're in them.
We're in them. We're in them nonetheless.
Want it or not, we're here.
So if you got comments about this, you please leave them in the YouTube comments there. We would appreciate that. Like, share, and subscribe. All that stuff seems to matter, and we'd like to be the biggest YouTube networking channel in the world. And we're never going to catch Network Chuck at all. That's not going to happen. So
Network Chuck. I was going for Mr. Beast. Let's have some ambitions.
Think small,
here.
Go big. Thanks for listening, guys, and we'll see you. We got lots more coming.